Hello friends, welcome back to the bench. Today we have an alternator, a Subaru Outback Alternator, although I do believe these are Mitsubishi alternators. This one stopped working. It was in my car, Subaru Outback 2008, with nearly 300,000 miles on it. I suspect that this is the original one, but I can't possibly know. I'm like a fourth owner of that car, so third or fourth. So it's impossible for me to know. I also struggled a lot because I replaced it in my car. Got the new one for about $130–140 off eBay. And the replacement procedure seems pretty simple, but there's a little caveat over here. This little bushing over here. Alright, that's gonna be when you replace the new one, you can just kinda tap this one back, then it slides in easy. I didn't know that, so I struggled a lot with it, but that was the first alternator I replaced on Subi. I replaced a few of them on cars like Ford, Fiat, Renault, Peugeot. Basically European cars. Now, I promised the folks on Subaru Outback forum that I would follow up with this. They assisted me in diagnosing whether it's for sure alternator and not something else. And the symptom in the car was intermittent. It would stop charging, then I would recharge the battery, and then it would work again for a few weeks actually. And then it would die again. But this time, when it died, it completely stopped producing energy. Now, the alternator needs to generate more current if the battery is discharged. So it's gonna have a lot more load on it. If the battery is charged, then it's gonna naturally consume less current. So that's what I think initially helped when I just recharged the battery. Then the alternator didn't need to produce that much current, and it would work again for a little while, and then it would die again. I wasn't sure, that's why I even disconnected it from the car to check its output when it was rotating, right? Still in the car. I just disconnected the big red wire and checked the voltage. That there was like 200 millivolts on it, something like that. So I concluded that the alternator is not generating current. Now let's see what happened to it. I pressure washed this one just so I can work on it. It's not perfectly clean, but it's a lot better than what it was. I do not recommend that you pressure wash your alternator. I just did that because even I'm not sure what I'm gonna do, whether I'm gonna fix this one or not. But again, I don't recommend that you pressure wash it. This is probably not good for it. It might cause rusting, and yeah, engines in general and engine parts in general don't like water. So no, don't pressure wash your engine, and don't mess around with pressurized water underneath the hood. Now, what do we expect here? So the way it works is relatively easy. We have a rotor and we have a stator, right? And appropriately enough, the rotor is rotating, the stator is stationary, right? On the stator we have coils, and on the rotor we have magnets. Rotating magnets, or magnets moving across the coils, induce current in the coils. From there, from the coils we go to our rectifier bridge, most likely full bridge rectifier. So we expect to see 4 diodes over there at least, and they are mounted on this heatsink over here. That's what I assume. From there, we need some kind of voltage regulator, because we want roughly 14.4 volts on the output, and no more than that. because otherwise the battery might get damaged. Not only battery, the components in the car, if the voltage is too high, could be damaged. Could get damaged through over voltage. So there's going to be some kind of, I expect, linear voltage regulator. So it's probably also going to be installed on some kind of heatsink. I'm not sure if there are smoothing capacitors in the alternator. I don't think I've seen it based on the videos that I've seen on YouTube. It didn't seem like there are, and I don't think there are required. And now this little pin, there is nice diagrams you can find how these pins are connected. The middle one has battery voltage, so I assume it is connected somehow to the battery. The one on the left will have 5 volts, and the one on the right, roughly, in my case, 0.8, but it should be anywhere from 0.5 to 0.9 volts. That's what I know. I don't know what they necessarily do and how this is connected, but that's how I diagnosed that it's most likely the alternator, not something else, based on these voltages. And I learned about it from Subaru Outback forum, subaruoutback.org. Great folks over there, always helpful. Now, when I unscrew these 4 screws over here, I will tap with the hammer and it should come apart. And the only part of it, because what's gonna break? The first thing that's gonna break are gonna be the brushes. Let me get this out and I'll show you. The brushes are here, and appropriately enough, this is the center, so the brushes are touching, there's 2 of them, and they are touching the rotor. Basically, that's basically a commutator. It just needs to connect the stator to the rotor, and since the rotor is rotating, you can solder in the wire, so the carbon brushes are used to make that connection. So this is something that will eventually be eaten out by the friction, and you'll just run out of brushes. So that's usually part that breaks and has every right to break, because it's experiencing a lot of friction, and after 300,000 miles it has every right to be broken. But as I replace, or as I take it out, the brushes will likely have made little grooves in the commutator. So when I take this out, I will likely break the brushes, because they're going to be holding the rotor. So let's see. I was tapping on the wrong thing, so this whole thing is coming out. So this was holding on the wires, and I thought this was supposed to come out. but now this was supposed to stay in. I don't think I've broken wires. Doesn't seem like it. So that's good. Now the brushes are good. See? I mean good. I think they are short, and that is probably what caused the issue. They probably don't make a good contact. And okay, that's another issue. So you see the commutator, or whatever it's called, it has so much gunk on it that it doesn't conduct. But even if I clean it, the brushes are too small. Brushes need to be replaced. So that is our issue here. This needs to be removed either way, right? So we can put the screwdriver over here, so we can unscrew this screw over here. These two have good access, but this one not so much. So either way it needs to be done like so, just so we can put the screwdriver in over here. Then this whole assembly pops out and we can replace the brushes. Now as we replace the brushes have a little notch on them, so we push them in, we put a little wire over here or something to hold them in, and then we replace the rotor and remove the wire so the brushes can sit. The bearing, I can't really show it on the camera, but as you rotate it, and it's actually the most noticeable when you rotate it when it's still inside, when you still have a lot of weight over here, and it makes rattling sound. Hear that? It shouldn't be doing that. So this bearing definitely needs to be replaced. To replace the bearing, you need bearing removal tool that will just grip it from the outside, and you screw the screw in here so it pulls the bearing, and then you replace the bearing with a hammer. So that is point number one. Now let's see the state of the commutator. If it doesn't have any cracking or anything like that. Well, you tell me if this looks good. I would probably do something about it, but I'm not sure how this can be replaced. It looks like it's soldered on, so we would have to desolder these wires and probably remove this whole thing. And that's probably how it should be removed. Now let's see some physical damage perhaps. It's definitely more dirty job than what I usually do. There are signs over here that it has been scratching, and we have the same signs over here on the stator. But I do believe that just replacing the brushes and this bearing, although probably, I don't know, there's no play on it, right? It's just worn. So even if we left this bearing in, the alternator would still work because it just can't, yeah, as you look at it, Yeah, well, you tell me. I think the brushes are too short. But let's put this back in, and let's do a little test. Let's try to push it back in. Yeah, it's blocking on the brushes. Yeah. Is it though? Yeah. Yeah, I think it's blocking on the brushes. So that means the brushes are technically touching. So I think the only issue here was just dirty commutator. That's why the problem was intermittent. And actually the problem started when the humidity went up. It's you know, I live in Georgia. It's pretty humid environment. It rains a lot. But the new brushes, when you install new brushes, they go almost all the way to the center here. And these barely stick out. So either way, the brushes need to be replaced. But I don't think the short brushes were the issue here. Let's get a little, maybe a little screwdriver. Will that work? Works for one of them, not for the other. And the reason it doesn't work for the other is because we ate through the brushes and there's no longer that little hole that you put the screwdriver through. So let's see if we can push the brushes all the way in. Okay. Now, so what I did, I pushed the brush all the way in and then put my screwdriver through here. Oh my god, the focus on the camera is awful. Sorry about that. If you guys can recommend any camera that doesn't do that, definitely drop it in the comments, because yeah, it is annoying. Doesn't want to lock in, but that's fine. So what I want to do is just put it back in. Oh, I broke the screwdriver, that is fine. Okay, now it's spinning. Now it's spinning. So I assume brushes are connecting now. So let's do this. You're gonna get the power bank connected. To the oscilloscope. Okay. Now, okay, I usually test it like this. Do I get interference? I do, so it's working. And now, let's see if we can somehow do it here. No, better. It's jumping to triggering voltage, but just moving it like this doesn't produce any current. But I assume that is okay, because I've done this with few other alternators back in the day, and I never got any reading by just doing this. I assume it's just not fast enough for actually producing enough, because this is linear regulator in there, right? It's not gonna start conducting, or it's not gonna allow voltage to pass through unless it is proper value, right? Proper potential. So this likely needs to be turned a lot faster. Now this could be done if we just put the cap, the socket wrench over here and connect it to the drill. We could simulate that, but that's besides the point. I just wanted to check if I'm gonna get any readings on it, and I'm not surprised that I'm not getting. I mean, I always done this test also out of curiosity, because usually with the alternators, the repairs that I've done, we're just cleaning. Because the same way here, if there is any gunk on the commutator, it's not gonna work. But you don't need to disassemble it to do it. You just need to get it out of the car and just spray. I use the gasoline, regular gasoline. I just spray it in there, and that removes all that gunk. Especially when you have oil leak and it leaks on the alternator, it will also stop producing. But this one definitely needs a, because you can see I didn't put it back correctly, right? So it's not aligned, so I can't screw it back together, because it still needs a brush replacement, right? But the construction is very nice. It's relatively easy to take it apart. Maybe not the easiest part out there, not the easiest procedure out there, and as you can see, you make a lot of mess doing that. There's also signs of cracking over here, or those little parts. Those are the parts of the stator. As I was hammering it, it started shedding some parts, so that was not good. Also, I made some damage over here as I was hammering it, and all that hammering was not necessary. I just should have hammered on this side, not on this side. So something to know now. Hammered this side. So this side, the stator stays on this side. I thought the stator was staying on this side. Well, you learn every day, right? Luckily, I have a new one already installed in the car, so I don't really care about this one. And the focus, there's the focus. Alrighty. I think we're gonna stop here because there's not much we can do without a replacement brushes. But other than that, one last measurement, because that could actually be an issue here. Regular multimeter. In the diode mode. Is it in that? No, it's not in diode mode. No, it's in diode mode, right? And that tells you a voltage drop. Between the positive output and the chassis, you should have a diode reading. That's a good diode reading. Half a voltage drop. So that tells me that the diodes are okay. There could be, because I was thinking, how did this one break? And well, now I see that that there's no way this could have worked with a commutator having this much gunk on it. So just cleaning, if I just sprayed it with some degreaser, be it a gasoline or something else, the problem probably would have gone away for another while. But I was thinking, before I disassembled it, I was thinking what could have broken, what would be the fault, and I was suspecting that diodes, either diodes or voltage regulator, were faulty, because I have a tire issue. My tire is slowly leaking air, and I kept it like that for a few months now. Instead of replacing or fixing the tire, I would just, every 2 days, I would just pump it up, right? Because it holds for about 2 days. So this was not something that I needed done right away, but I should have. And why I should have done that is because I connect the tire inflator into the lighter socket. The pump takes about 7 amps at roughly 12 volts. So that's a lot of power. Plus, it needs to recharge the battery, and it needs to power the rest of the vehicle. So we don't use the battery power, but rather power coming from this. Now 7 amps, that is a lot. That's 80, close to 100 watts. And doing that every time my tire goes low, so roughly every other day. So I thought I just killed it because of that. That's abnormal power consumption from this. So I was expecting a diode or a voltage regulator to be faulty. But as soon as I replaced the brushes, clean the commutator again and clean everything here, put it back together, and I may well, that will have to be a time when, because I also need to replace the bearing here, right? But if I do all that and I still have some spare time, I will put it back in the car and see how long it will run. I will hopefully become a little more proficient at replacing it. Instead of taking an hour to replace it, maybe I can take 15-20 minutes to replace it, because it shouldn't be much longer than that. I think I took way over an hour, and I got pretty tired. If you do something for the first time, it's a lot harder than doing it for the second time. But that is the plan for this alternator. I hope you at least found it interesting as far as how to disassemble it, or how not to disassemble it, and how to diagnose it. I think other than short brushes and that bearing, nothing else is wrong with this one. So I may restore it and maybe even sell it. They go for about 50 to even $80. The alternator, without even specifying whether it was whether the brushes were replaced or bearing or anything was done with it. Most likely it's just salvaged from the car and just sold as is. It's a good business. So maybe that's what I will do with this one, but for now this will wait until we have some more time, because I have other stuff to do. Imagine that. Alrighty, thank you guys very much for watching. I hope you found this interesting and perhaps useful, and I shall see you in the next one.